Okay, folks, we're going to set up some notes and try to crank out today's homework. I don't think the concept is going to be difficult for you. I think you're going to look at it and go, oh, okay, this isn't so bad. But there is a fair amount of vocabulary. Like when it says determine if an expression is a polynomial, this is all about vocabulary. And then adding and subtracting polynomials is going to just be like, you know, straightforward algebra 1 type stuff. And I think I can make that super clear. The vocabulary, it sounds kind of difficult. Like when it says what's a polynomial, what is a polynomial? Let's look over at the book for just a second here. And I just want to remind you, we do have a textbook, right? We don't often, pull the textbook out, but right here it says a polynomial is a monomial. Well, what the heck is a monomial? Or the sum of two or more monomials. Well, we got to go down here. We got to figure out what a monomial is. It's a number, a variable, or a product of numbers and a bunch of variables. It could be a lot of numbers and variables. So let's write a little definition up here at the top. I'm going to try just to type it in here. And I would say a polynomial is one or more monomials. And what is a monomial? It's a number, variable, or a product of numbers and variables. Okay? So I'd like you to put that down. And then we're going to fill out this little table here, and we're going to try to figure out, which ones are polynomials and which ones are not right now, okay? And I'll get back to this, what's a monomial, a binomial, a trinomial. We'll talk about that here in just a second, all right? So you can see z to the -2. Well, that's the same thing as 3 over z squared. So this is not a polynomial because there's a z in the denominator. You can't divide by a variable. You've got to have the product of variables and numbers. And so since we're dividing by a variable, it's not a polynomial. So you don't have to fill out this part about degree. I haven't talked about what the degree of a polynomial is. And we don't have to classify it because since it's not a polynomial, we don't have to worry about those. This one is a polynomial because you have 2 times x times x times x plus x minus 12. So yes, it is. It's just multiplication and addition and subtraction over here. So that's totally fine. We got a monomial, a monomial, a monomial. There's 3 of them. So this is called a trinomial. So the word tri means there's 3, and mono means there's just 1. So one term is like this guy right here. That's a monomial. Let me jump down here and call it a monomial. And then this previous one that we were talking about is a trinomial because there's 3 terms. Trinomial. All right, so I'm hoping you're hearing my audio. If you're just watching this, that's pretty hard to figure out what I'm talking about here. So just 1, so this is yes. And this is 2 terms. There's a term here and another term here. So 9 times x minus 2, this is called a term of the polynomial, and this is another term. And so since we have 2 terms, it's a binomial. And since there's just, multiplication going on and subtraction, we've got a yes, it is definitely a polynomial. Now let's talk about the degree. The degree isn't that hard to figure out. The degree is the term that has the highest amount of exponents. In other words, like this term right here has 3 for its exponent. This term only has a 1 over here. So you look at this particular term and it has a degree of 3. And it's the highest combined exponents for all the variables of that term. Let me just say it that way. Well, you might say, well, there's only 1 variable here. Yeah, but it could be like if it was, let's say instead of that, let's just do a similar example here. Like if it was 2x cubed y z to the 4th power, you'd have to take the 4, the 1, and the 3 and add them all together. You'd say 4 plus 1 is 5, plus 3 more is 8. So then the degree of the polynomial would be 8 right here, okay? If that was instead of 2x cubed, let's say it was 2x cubed y z to the 4th, okay? So I hope I'm making degree clear. I'm going to undo all that stuff because that's not what we had going on, right? We had just that basic polynomial over there. And so the degree was 3. Here, the variable has a 1 for an exponent, so the degree is 1. Here, the variable has an exponent of 1, so it's a 1. I hope I'm making degree clear. It is the combined highest value for the exponents of one particular term. So I'm going to put down combined highest exponent on one particular term, on a term. And you want the highest value of all the terms. So like I didn't choose this for my degree because it wasn't the highest power. This was the one that had the highest power, okay? This, by the way, is in standard form, this polynomial, because it's going from highest power, next highest power to lowest power. This one's in standard form. There's only one term. This one's in standard form because it went from x to the first down to x to the 0 power. Like you could think about an x to the 0 here. So we're going degree 3, well, a power of 3, a power of 1, a power of 0. You want them in descending order for exponents on the variables, okay? Now, why have we stopped talking about, example A? Because it wasn't a polynomial, right? So you don't have to worry about degree. You don't have to worry about how many terms it has because it's not a polynomial. All right, so now we're going to talk about how do you add and subtract. Before we do that, let's do a couple quick practice problems that you might see in your homework today. So let me move this over here and let's go to this next page, okay? So determine whether each expression is a polynomial. All right, well, this one is not because it has a divide by x squared. That's what makes it not a polynomial. This one is a polynomial because there's no division by a variable. This is a monomial, even though it's just a constant. It might make you feel uncomfortable because there aren't any variables here. But I mean, you could think about it as like x to the 0 power or anything to the 0 power here, but that's not necessary. You don't have to do that. I don't want to confuse the issue. This is a polynomial right here. It's a monomial, right? This one has 3 terms, so it's a trinomial, right? So you've got to also classify them. So you're going to say this thing's a monomial, this one's a trinomial, right? And then if it asks for the degree, which it does right over here, the degree, you're going to pick the highest power. So this has a degree of 4. All right, this has a degree of 4. This one back here was a degree of 0 because it doesn't have a, like a variable. The variable that it would have would be a x to the 0 power. And let's see, what else does it want me to do? I mean, this one, by the way, is not in standard form. I would write down negative a squared plus a. It doesn't ask for the leading coefficient, but if it did ask for the leading coefficient, once you have it in standard form, you take the coefficient that's in front of your first term, and the leading coefficient is equal to, add this to your notes, please, the leading coefficient is -1 on that one. The leading coefficient over here is, ooh, I almost got fooled here. Here's the one that would have the highest power right here because there's an n to the first and there's a q to the third. So let me scrap that idea. If we wrote this in standard form, I'd write nq cubed plus 5n cubed, and I've got a degree of 3. So this is a polynomial. Why did I say 3? I didn't mean to say that. I've got a degree of 4 because the power here is a 1, the power here is a 3. So I got a degree of 4, right? Oh man, I hope I'm making this clear. That's all just vocabulary stuff that we have to manage today. And then what we were saying over here is, is the polynomial in standard form? Now this is more classic, polynomial-ish, and it's not in standard form, so we're going to rewrite it 5x squared plus 3x minus 2. Now it is in standard form, and here's my leading coefficient, right? So the leading coefficient's 5. And the degree is equal to 2. The degree equals 2 because that's the highest power right there. There's only one variable in this term, and so I don't have to add exponents, but I've got just a 2. So I'm hoping I'm making that clear. This polynomial over here has how many terms? 1, 2, 3, 4. I don't particularly give it a special name. It's just a polynomial. This is the one with the highest power, so it's in the right place. This one's the next highest power, so it needs to switch locations with this guy. So if I was going to write it in standard form, I'd do -y cubed minus 3y squared plus 3y plus 2. Now it's in standard form, okay? All right, let's get to adding and subtracting in our notes. So I hope you've added a few things to your notes over here, and you're making them your own. And now we're going to talk about how do you add and subtract polynomials. So, my organization might not give you space to put a couple examples, but I want you to write some right over here. And I'm going to jump to the homework and we're going to try a couple together. All right. So I want to try to add these two binomials together. And the parentheses are completely unnecessary. I think they're there almost just to confuse us a little bit. So the book talks about a way of grouping like terms together, and they call this the horizontal method. So I'm going to go 2x plus 4x. So I'm joining these two together inside some parentheses. Now I'm going to join the other two like terms together inside the parentheses. So I'm going to go plus, and in there I'll put those in red just so they kind of stand out. So we get 3y plus 9y. So I'm adding the like terms, and you've heard this a million times, So hopefully this feels comfortable to you. 6x, and then we've got what, 12y. There aren't any negative signs up there, so I've got just straight up addition. That's how you add two, expressions together. We're just adding like terms, adding polynomials here. How would you subtract them? As you can see right down here, we've got a minus. Well, I would distribute the negative sign through. So I'd take this negative sign and I would distribute it through. And so now we've got something like this. I'm going to get rid of the parentheses altogether. I'm just going to put down 5a plus 9b minus 2a minus 4b, because I had to distribute that negative sign over. This became a negative 4b. This is a negative 2a, right? Or I'm subtracting 2a. Now I'm going to look for my like terms. So these two guys here are like terms. So let's write those guys down. 5a plus, oh, it's a minus. Uh-oh, let me undo that. Doggone it. So it's a 5a minus 2a. And then I've got a 9b right here, 9b, and a 4b. So, and they're subtracted, so we got to be really careful here. Plus 9b minus 4b. And what do we end up with? 3a. You notice how I didn't put parentheses around these? It's not necessary. I can see these are my like terms. I got 3a from them. These two subtracted from each other, I get 5b. So I'm going to put down plus 5b. Okay? Let me show you what they call the vertical method right here with number 16. So I have enough space, I got to put it down here. So I'm going to copy 6s plus 5t down. Then I'm going to take 4t and I'm going to put it right below its like term. So I'm rearranging right now this one so that they're lined up, and then 8s is going to be right below. And it's addition here that we're adding those two terms together. So I want to make sure I got the correct signs, and this is addition here. So now I'm just going to go like vertical here and say 14s, and I'm going to make that look kind of like more like an S instead of a 5, so it doesn't look like 85 or 65 up here. And then we've got 9t. This is how you add two polynomials together. You're looking for like terms and just adding them together. I hope I'm making this clear today, that you feel confident and that you're able to complete the homework. Thanks, everybody.